Okay, hello again. Let's talk about profit maximization. Last time we talked in our last video, we talked about revenue maximization. This time we're going to talk about profit maximization because it's a little more involved. Okay, first let's create a problem. You have inherited a downtown parking lot from a relative. You worked in this parking area, parking cars and collecting money, so you're quite familiar with the operation. When you start a business, you charge $60 per month for parking and currently have 3,000 cars. You've noticed that for every $6 decrease in price, you get an increase of 600 cars. You also have calculated that there is a $12 cost per car per month, which includes security, tickets, ticket machine maintenance, area maintenance, and personnel. Now let's talk about profit maximization and what it is. Profit maximization is when a business can sell a product so that its marginal revenue equals its marginal cost. When the value of the marginal cost is rising. Okay? This means this. There will come a point in the production and sale of your business product that if you would sell one more product, your business would lose money because the cost of producing that unit of product would exceed the price of the unit on the market. Okay, and I'm going to show you that in a chart and how we look at that. Okay, let's derive the equations. Okay, total revenue we're going to call TR. Total cost we're going to call TC. So total revenue equals price times quantity. Okay, and that's what we did last time with total revenue. Okay, and total cost equal cost times quantity. And profit equal total revenue minus total cost. Now, I want to throw a little tidbit in here. Let's call change equal delta. That delta symbol right there. So the change in total revenue equals delta TR. Change in total cost equals delta TC. And the change in quantity equals delta Q. So the change in total revenue divided by the change in quantity is equal to your marginal revenue. And the change in the total cost divided by the change in quantity equals your marginal cost. So profit is essentially equal marginal cost minus marginal revenue minus marginal cost. Okay. Profit equals change in total revenue divided by the change in quantity minus the change in total cost divided by the change in quantity. That's just a little note. I want you to see that. Let's keep going. Okay, here's our problem again. And as we said before, total revenue, total cost, and profit. Okay, what is price? Well, here's price and total revenue. So price is equal price minus discount. And in our problem, we said we charge $60 per month. So that's price equals 60. And our discount is $6 decrease in price. But how many times we're going to do that? Well, I don't know how many times. So we want to maximize that. So we'll say we got $6 decrease times X, where X is the number of discounts allowed. Okay. What is quantity? Quantity equals quantity plus increase from the discounts. Okay. So our quantity is 3,000 cars. And every time we give a decrease of $6, we get an increase of 600 cars. So 600 times the number X, the number of discounts we allow. So that's our quantity. Okay. So there's the equation we derived before, price and quantity. So our total revenue is equal 60 minus 6x times 3,000 plus 600x. Okay. Price times quantity. And our total cost is equal to, from our problem, we charge $12 per month cost times the quantity, which is 3,000 plus 600. Okay. So let's take our total revenue equation and do the multiplication. We have first term, second term, first term, second term. So we go first term times first term times second term times first term, second term times second term. So okay, let's do that. 60 times 3,000, 60 times 3,000, plus 60 times 600x, 60 times 600x, minus 6x times 3,000, minus 6x times 3,000, minus 6x times 600x, minus 6x times 600x. And if we do that multiplication, we'll come up with 180,000 plus 36,000x minus 18,000x minus 3,600x squared. And our total revenue is minus 3,600x squared plus 18,000x plus 180,000 is our constant. Okay, what is our total cost multiplication? So we have 12 times 3,000 is 36,000, and 12 times 600 is 7,200x. Okay, so 12 times 600x is 7,200x. Okay, and our profit is equal to the total revenue minus the total cost. Okay, so our total revenue right there minus the total cost. So that's minus 36,000 and minus 7,200x. And if we do the addition there, we have our profit is equal to minus 3,600 times x squared plus 10,800x plus 144,000. Okay, here's our profit maximized. Now we got to plug this equation, maximize profit, into our vertex form. And how do we do that? Well, we remember from a standard equation in our last video, and I'm not going to go through that again. Look at my maximization of revenue video. We went through this in detail. So A is equal to, in our standard equation, A is equal to minus 3,600, B is equal to 10,800, and C is equal to 144,000. So if we plug all of these into the vertex equation, we'll get our vertex equation maximized. Okay, so minus b over 2a is equal to minus b minus 10,800 divided by 2 times a, which is minus 3,600. And if we do that multiplication, minus b over 2a is 1.5. And 4ac minus b squared over 4a, if we plug in all of these constants into here, this equation, we'll get 152,100 for that term. Okay. So our equation will come out to be profit is equal minus 3,600 times x minus 1.5 squared plus 152,100. When x is equal to 1.5 discounts, your profit is maximized at 152,100. When x is 1.5, this is 0, and 0 times anything is 0. So our maximum profit is $152,100. Okay? Let's use the results to answer these questions. What is the price you charge per month? How many cars do you park per month? What is the cost to the business per month? What is your maximized profit? From this equation, we can answer these questions. Okay, let's continue. Here's our maximized equation. Here is our total revenue and total cost. Okay, let's answer these questions. Price. What is price? Well, here's price equation right there. 60 minus 6 times x. Okay. Well, x is 1.5 right there. Okay. So 60 minus 6 times x is 1.5. 1.5 times 6 is 9. And 60 minus 9 is $51. So our price we charge is $51. Okay. How many cars do you park per month? That's quantity right there. Okay. So 3,000 plus 600 times x. X is 1.5. So 1.5 times 600 is 900 plus 3,000. Our total quantity of cars we park is 3,900 cars. What is the cost to the business per month? Our cost is right there. Our total cost. 36,000 plus 7,200x. X is 1.5. So 1.5 times 7,200 is 10,800 plus 36,000. Our total cost per month is $46,800. What is your maximized profit? Maximized profit is at x equal 1.5. That's 0. So therefore, our maximized profit is $152,100. Let's look at a graph and chart. Okay. So here is my chart here. Okay, so here is my chart, and I've taken out maximize the equation here, right there, and I plotted this graph. And what I did was I plotted the whole graph because I want you to see the whole parabola. Okay, and that A is minus 3,600, so that means the parabola is opening downwards. Okay, and x is 1.5, so x is 1.5 right there, and so by x being 1.5 right there, that's at the peak of the parabola. So the arrows show that going up the left side of the parabola, we're right there, starting out from -3. The cost is $14,400. The price is $78, and the maximized profit is $79,200. And how you do that is you take. I started this out at -3, so let's do that. Let's do that calculation. So let's do cost. Okay. So x is equal to -3. That's -3 times 600 times 600. Okay. Plus 3,000 times 12. That's 14,400. And that's what we got there, 14,400. Okay. Now, what I did was I started from the left-hand side and I went all the way to the right-hand side. And I want you to see that because I want you to see the whole chart. And as you go down to the left-hand side, you'll see the price is $24, and the cost is $79,200. See, cost and the maximum profit. And let me do it. I do this. And let me do this. And so the maximized. So at $24, at $24 cost, all you can do is pay for the, at $24 price, all you do is pay for the cost. You know, because the cost is $79,200 and your maximum profit is $79,200. So the lowest price you can have is $24 per month per car. Okay. Now, when X is 1.5, there's your cost, $46,800. Your price is $51. X is 1.5, and your profit is maximized at 152,100. Okay. And as you can see here, as you're going up the left side of the chart of the parabola, your cost is increasing, but so is your maximum profit. Okay. And as your cost is increasing, once you get to the top, everything stops and settles down, and you're maximized. You're maximized at the vertex. Then, once you pass the vertex, and let me bring that back here for you again. Once you pass the vertex, right here, once you pass the vertex where you're maximized, and you go on the right-hand side of the parabola, your cost begins to increase, and your maximum profits begin to decrease. And you'll see that. Okay. You start losing money. Okay. And you just plug into these equations and you can get whatever you need right there. Okay. Okay. That's about it on profit maximization. Maybe I'll come back later time and later date and do a few more examples to help you out on that, so you can do a few by yourself. But profit maximization and revenue maximization is pretty neat. Business loves math, and so should you. I hope you enjoyed that, and I hope you learned something. Until next time.